A great day to one and all. Welcome to this beautiful Sunday morning for our class. So let us all be reminded that we are in the most holy presence of God. Lord God, Heavenly King, Father and Lord, we worship, praise, adore, glorify, and love you. Thank you so much for everything. And we are hoping and praying that we will have a productive discussion this day. All of this we pray in Jesus' name. Amen. Okay. Good morning, everyone. And I hope that you're having a great day today. So this is a beautiful Sunday morning and we will have our class again for today. Okay. So please permit me to stop my video because I'm afraid that I might lose my connection. Okay. So again, be reminded that if you have questions or clarifications, feel free to chat. Okay. Okay, so for the meantime, I will change the settings, no? Because there are some instances that I will be asking questions gali. So, and I need to for you to respond, no? But again, as much as possible, if there are unnecessary background noises, no, let us mute ourselves so as not to disturb others. Thank you. So our topic for today will center on statistical tables, measures of central tendency and dispersion. Because later on, when you have your when you will do your chapter 4, you have to present your data by means of tables. When we speak about statistical table, it is a way of presenting statistical data through a systematic arrangement of the numbers describing some phenomenon or process. When we speak about mass phenomenon, you are not going to report only the phenomenon experienced by an individual person, but you are going to report, for example, means or averages or measures of central tendency and variability of a certain group of people when you take them as a whole, for example, or when you group them according to certain stratum or strata. So a statistical table has at least four major parts. Parts 1 to 4 are the major parts, whereas parts 5, 6, and 7 are optional parts. Okay. So we have here the title, the box head or the column captions, the stub or row captions, the body, the prefatory notes, footnotes, and the source notes. Let's discuss them one by one. Okay. Please take a screenshot of this, no? Please take a screenshot of this. Okay. Because later on, I will be giving you a bit of an exercise related to this. When we speak about the title, it is the main heading written at the top of the table. It must explain the contents of the table and throw light on the table. As a whole, different parts of the heading can be separated by commas. There are no full stops in the title. Also, the title may contain the table number. So the title would usually contain or tell us what the table is about. And usually it's written at the top, no, of your table. So the second part is what we call the box head or the column captions. So column captions, these are the vertical heading and subheading of the columns are called column captions. The spaces where these column headings are written is called the box head. And so if you could see here, no, may mga labels. If there are labels here on top, so we have here, you could see here your box head and your column captions. The third is what we call the stub or the row captions. The horizontal headings and subheadings of the row are called row captions, and the space where these row headings are written is called the stub here. So this one is going horizontal. And the fourth important part is what we call the body. This is the main part of the table, which contains the numerical information classified with respect to row and column captions. So In this part is where you usually write the numbers, no? Or the both quantitative or qualitative data that you have. So the first four are what they call this are required. The next three are actually optional. The fifth one is what we call prefatory notes. This is a statement given below the title and enclosed in brackets, usually describes the units of measurement and is called the prefatory notes. So for example, weight of the students, tapos lalagay in kilograms. So the in kilograms is your prefatory notes. The sixth one is the footnotes. These appear immediately below the body of the table, providing additional explanation. For example, in the footnotes is where you place the legend or the scale of means, no? And the number 7 is what we call source notes. Source notes are given at the end of the table indicating the source the information has been taken from. It includes the information about compiling agency, publication, etc. So the source notes, for example, if you copy the table from someone else or if you adapted the table from a certain book or author, you have to acknowledge the source. And this is where you write the notes or the source in the source notes. Do we have any questions so far, moms and sirs? Okay, so let's try the following. Okay, now this time I would like you to identify the part. Just type number 1 if it's title, 2 if it's box head, all the way until 7 if it is the source notes. Write the number only. For example, this is the table that's found in my thesis, in my master's thesis. Now, what do you call this part? Is it 1, 2, 3, 4, 5, 6, or 7? This is what?
Title, sir.
Yes, number?
1.
Okay, tama. That's number 1, which is the title, the demographic profile of the respondents.
Okay, sir.
How about not this one? Please type in your answer na lang siguro, okay lang? Please type in your answer in our chat. Okay, Ma'am Abigail said 4, and I agree, no? 4 is correct. This is the
4.
body. Tama po. How about this one? You see their entire group, school type. School type, you have 3, no? Private all boys, public co-ed, private co-ed. Ma'am Abigail said 3. The stop or row caption said, Ma'am Nela also said that. If you said 3 or the stop, correct. How about this one? The N and the percent there.
Oh, thank you. Good night.
5. Is it 5? Is it prefatory notes?
Number 7, sir. Source notes.
It is. Ang sa babaw, dili pala ho? This is the the box head or column captions. So it's 2. So careful ha sa babaw. How about the next one? How about this? What do you call this?
Ano to?
Number 7, sir.
Okay, number 7. If you say source notes, that is correct. Okay, good. How about this?
Where is what's the footnote?
What do you think?
Footnotes is footnotes, sir. Number 6, footnotes.
Okay, it is. If you answer 6 or footnotes, you are actually correct. So I
Yes.
hope, no? I hope it's clear sa atin. Now, I hope it's clear because later on when you make your tables, some of these parts, the parts 1 to 4 have to be present, but the other parts may be needed also sometimes.
Okay.
Okay, let's talk about measures of central tendency and variability. So these are examples of what we call summary measures. No? So we have measures of central tendency, namely mean, median, and mode. For measures of position, we have quartile, decile, and percentile, some of them. We also have measures of variation or variability that was, and I think I gave a quick introduction of this yesterday. So for variation, we have range, variance, coefficient of variation, and standard deviation. Now, but for this course, we will focus only on measures of central tendency and variability because normally we don't use the measures of position in our thesis. No? Now, a measure of central tendency. Okay, would you mind reading this one for us? Ma'am Florence, would you mind reading po?
Okay, sir. A measure of central tendency for a collection of data values is a number that is meant to convey the idea of centralness for the data set or simply defines the summary statistics. And it is a representative value of any given data set.
Okay, thank you. Just like what I mentioned yesterday, even though you have multiple numbers in a data set, there is a number that could best represent that data. And that is an example, and that is your measure of central tendency. So we have 3 of them. We have what we call the mean, the median, and the mode. So many of us are already familiar with this. So let's just go over them one by one. When we speak about the mean, it is computed by summing all the observations in the sample and dividing the sum by the number of observation. No? So just like what you did yesterday, just like what we do in our class, to get the mean or arithmetic average of the score of the students' grades for the 4 quarters, what we do is we add all the grades from first to fourth grading period and divide the result by 4. It represents the center of your data. However, for you to do this, your data, di ba, meron tayong 4 na measures of measurement. We have 4 of them, levels of measurement. I mean, we have nominal, ordinal, interval, and ratio yesterday, remember? For you to determine the mean, your data must be at least interval. Meaning to say, your data should either be interval or ratio only. If your data is nominal or ordinal, then the mean cannot be computed. And it is the most stable measure, presuming again that there are no extreme scores. Okay. So we have here 2 different notations. So we have here mu, and you see no in this summation symbol, capital N ang sa babaw niya, yung sa kanyang itaas. And here it's just small n. So this is the notation for population mean. And this is the notation, the X bar, for the sample mean. Capital N here is the population size, whereas small n here is the sample size. So they just differ in the notation slightly, no? Considering that population utilizes the capital letter here, whereas it's just a small letter here. But don't worry about the complicated symbolism because it just means that you just add everything and divide by the number of scores. For example, let's have the following. a particular quiz generated the following scores of the 8 students in a class. Their scores are 8, 11, 5, 14, 8, 11, 16, and 11. Considering this quiz as the statistical population of interest, meaning you have 8 students, all of your students, there are only 8 students in your class, for example. Considering this quiz is the statistical population of interest, what is our mean score? Okay, so what are we going to do? We are going to add these scores and divide the result by what?
84 divided by 8 equals to
Okay.
10.5, sir.
Okay. So the sum, no, of all the scores is 84.
84
And
over 8.
since
mean
there are
You will
8 scores, we
divide
divided
it
this
to
sum by 8.
Yes,
And
and
you
the
will get
answer is
10.5.
10.5.
Thank you. This means that the mean scores of 8 students in a particular class showed 10.5 points. Okay? All right. Now, so that's your mean, no? So we are all familiar of that. Apart from the mean, there are some instances that one component or some numbers or some components have greater weight than the others. For example, in our class, no, in mathematics, written works is 40%, performance task is 40%, and quarter test is 20%. So you see, there are 3 components, but they don't possess the same. All of them do not possess the same weight. So we also have what we call weighted mean. It is also called weighted average, in which each value is weighted according to its importance in the overall group. So here's a symbol for weighted mean. And to do this, we will multiply each number, no, with its weight. Then after multiplying the number or with the weight, you will get the sum of all of these products and divide it with the total number of units or weight. No? For example, what is the average for a student who received grades of 85, 76, and 82 on 3 tests, and a 79 on the final examination in a certain course, if the final examination counts 3 times as each of the 3 tests? Okay. So you could see, no? Ang tatlo ka test nga ni, 1 unit each lang. Assume ta nga 1 unit each. Pero ang final examination, it says here, counts 3 times as much as each of the 3 tests. What does this mean? It means that if each of these 3 tests is 1 unit each, then the final examination is how many units? How many units is the final exam? Or pila, or what's the weight? It's 3 units, right? So, meaning to say, we will multiply each of 85, 76, and 82 is 1 unit only. So 1 times 85 plus 1 times 76 plus 1 times 82.
Yes.
However, you might be wondering, how come we multiplied the final exam, which is 79, by 3? Because again, the final exam is 3 times the weight, no? That's why 3 times 79, and after that, you add. So so you add everything. So 1 times 85, 1 times 76, 1 times 82, plus 8 times
Or 80,
79.
sir.
But you might be wondering, sir, why did you divide by 6? Because 6 is the total number of units. There are 6 units, no? 1 unit, 1 plus 1 plus 1 plus 3, 6 units in all. That's why if you use your calculator, this student will get an average of 80. Questions?
Yes, sir.
All right.
Oo.
Okay. So that's for your weighted mean, no? Especially if you can use this if not all components have the same weight. Let's talk about the median. Okay. May I assign you, Wenzel, Dueñas? Please read for us. Median. Sorry, I think di siya kabati sa aton. I'm not sure. Ma'am Christine, is it okay if you read ma'am for us, ma'am?
Useful for summarizing skew distributions, center of an array arrangement of the data from lowest to highest, equal to the mean for symmetric distributions, divides the array into two equal parts. Data must be at least ordinal.
Okay, thank you. So usually, no, when we say skewed distributions are not balanced. They are not symmetrical. Meaning, when we say skewed distributions, the data, for example, many got high scores or many of the scores are low. So that's an example of skewed distributions. So it's a center of an array. So when we say array, for our case, it's assumed that the data is arranged from lowest to highest. And it is the number or a value that divides the array into two equal parts. The numbers less than the median belong to the lower half, and the numbers that are at the right of the median belong to your upper half. And it's equal to the mean for symmetric distributions. But again, you can only use this if your data is at least ordinal. Meaning to say, if your data is either ordinal, interval, or ratio, then the median may be computed. So here is our sample, no? Our notation for population median. It's mu with a tilde. For the sample median, it's x with a tilde. And we have two rules for median. That is, if you have even number of scores or if you have odd number of scores. If the number of scores or the number of elements is odd, the median is the middle number. But if it is even, then the median is the average or the mean of the two middle numbers. Again, if odd, whatever the middle number is, that's the median. But if there are even number of scores, then you have to add and divide by 2 the two middle numbers. All right. For example, let's have the following. A particular quiz generated the following score. Same mangyapon. It's still the same. Find the median. First and foremost, what should we do? Anyone? What should we do? Because remember, we can do this only if it is an array.
We will arrange, sir.
Exactly. So we have to arrange the scores first from lowest to highest.
Yes.
And that array will be 5. Remember, if it repeated many times, you should also write it the number of times it appeared, no, on your in your data set. So we have here 5, 8, 8, 11, 11, 11, 14, 16. Okay, next. I hope it's clear with you, no? I hope that you can follow. Next question. There are 8 scores, right? There are 8 scores. Is 8 even or odd? 8 is?
Even.
Numbers and
It's an even number. And, diba, according to the rule, if the number of scores is even, you have to get the average of the 2 middle numbers. Take a look at the list. What are the 2 middle numbers?
11.
11.
What are the again?
11, sir.
11, sir.
11 and
11.
11 and 11, right?
Yes.
That's why to get the median now, all you have to do is add them and divide by 2. So 11 plus 11 divided by 2, that's 22 over 2 or 11, which means that the median scores of 8 students in a particular quiz showed 11.0 points. Okay. Questions or clarifications po? Okay. Now, how about this? But if you could see, no, how about if you have an odd number of scores? So I presented them already in this case, no? I have here 1, 4, 5, 7, 8, 9, 10. There are 7 scores here, right? And 7 is odd. That's why, since you have 7 scores, you could see that the middle score is 7. Therefore, the median is already 7.
Yes.
Take note, I also mentioned earlier that the purpose of your median is to divide your data set into 2 parts. All the scores at the left or the low at the left are lower than the lower at the left of the median. No? So we have 1, 4, 5. All scores here at the left are your lower or bottom 50%. Whereas all the scores at the right of your median are part of your upper 50%. Okay? That's why I hope you are familiar with the rules if we compute for the median. Okay. Now, let's have the following. How about this? So using the same problem earlier, it's the same, it's the same list earlier. Let's make what we call a dot plot. So we have here 5. Okay. You could notice how kamamune. Because we have, diba, the lowest score is 5. The highest score is 16. So I list all the numbers, all the natural numbers from 5 to 16. And in a number line. So 5, 6, 7, 8, all the way until 15, 16. So, di ba may 5 ka nga score dire? 5. You have 8. But there are 2 8s, right? Because 8 appeared twice. So first, you put here the 8. The second 8 on top. Next, you have what? You have 11. But 11 appeared 3 times. So you put 11 that way. And you also have 14 and 16. Di ba la? Your mean earlier was what? Your mean earlier was 10.5. So 10.5 is somewhere here. And your median earlier was also found out to be 11, right? So median is here. And you could see somehow, no, that since the mean and median, that 10.5 and 11 seem to be good representatives of the data, of the data set, since they are located in the center of the distribution where the points are. And you could also see that somehow they are nearer to each other. If in your case, the mean is far from the median, then most likely one of them is not a good measure of central tendency. But somehow, if they are near each other, somehow they are good estimates of your data set. Now, here's the thing. What if instead of 16, one of the students got 160 points? Then the last point on the dot plot will be very far from the result of the points, right? Or it's an extremely high value. And this extreme values are what we call outliers. When we say outliers, these are extreme scores, meaning extremely high or extremely low scores. And these scores are usually different from the majority of the numbers in the set. So, for example, di ba earlier, I have the array, gin-array ko na lang adaan. Earlier, the highest score here is 16. But what about, gin-islan ko ba ang highest score into 160? Now, what is our mean? The new sum will be 228, right? You could verify that. 5 plus 8 plus 8 plus 11 plus 11 plus 11 plus 14 plus 160. And that's 228 over 8. That's 28.5 points. Now, how about the median? Everybody, tell us what the median is.
The median is
Pila? Pila atong median? Kindly comment po sa atong nga GC.
11, sir.
Oh, 11. Okay, thank you.
11, sir.
You see, the median is still 11 points. So what have you noticed? What can you now say about the mean score and the median score above with an outlier? What have you noticed with the mean? Ano ang natabo sa mean? Did the mean change or not?
Does not mean.
The mean, it changed, right? Because
The mean
earlier the
changed.
mean was 10.5, but now it's 28.5. What have you noticed with the median?
Still the same, sir.
Come again?
Still the same. It does
It's
not
the
change.
same. That's why take note of this. The value of the mean is affected if there are extreme values or outliers. Hence, it cannot be used to represent the distribution if the shape is skewed. That is why one condition for its use as a representative value is that the shape must be symmetric. As much as possible, on the other hand, the median has not changed because only the middle value, if n is odd, or the mean of the two middle values, if n is even, is used. The extreme values is not used in determining the median. Therefore, remember this, mga moms, no? The median is a better representative value if the shape of the distribution is skewed or is not balanced. That's why if you have outliers or significant outliers, it's better to use the median than the mean. Tandaan ka na, ha? If there are outliers or many significant outliers or extreme scores, use the median than the mean. I hope I am clear with that. And let's talk about the mode. The mode is just the value that occurs the most often. And what's good also with the mode is that the mode is not affected by extreme values or outliers. It's used for either numerical or categorical data, meaning mode could be used for any level of measurement. If it is nominal, ordinal, interval, or ratio, the mode can be used. It may not be unique if it exists, meaning it's possible to have more than one mode. Or pwede man nga wala mode. Sometimes this value may not exist. So here's your symbolism. Capital M sub O is for the mode. Small m sub O is your sample mode. Let's go back here. Actually, is arranging the data set from lowest to highest necessary in determining the mode? And the answer is?
No, sir.
No, tama. Arranging them in an array or from least to highest is important for the median, but not for the mean or for the mode. Now, what score appears, but in my case, in-arrange ko na lang ha. What score appears the most number of times?
11, sir.
11. 5 appeared once, 8 appeared twice, 11 appeared thrice, 14 once, 16 once. So the highest frequency is 3, and that is the 11 as a score. Hence, the mode of 8 students in a particular quiz showed 11 points. Okay. Okay, take a look at this. Now, take a look at this set here. First set, 1, 3, 4, 5, 7, 9, 14. Why nga wala sang mode how? Take a look. Why is there no mode?
Wala siya
In 1, 3,
There is no
4, 5,
repeated
7, 9,
number.
14. Come again? Because?
There is no repeated number.
Because wala sang. Take a look at the first set. Is there a score na may nag-repeat? Wala.
No,
Wala,
sir.
What's the
sir.
first set?
Sir.
Wala. So remember this. In a certain data set, if all data or elements are different, meaning if no score or datum repeated more than, if no score was repeated, meaning wala na sang mode. Or if all the scores or data have the same frequency, then there is no mode also. That's why wala may nag-repeat, wala na sang mode. That's why it's possible na ang data wala mode. But take a look here at 1, 2, 3, 3, 4, 4, 5. You have two modes, 3 and 4. Nga two modes, 3 and 4. Because the highest frequency or appearance is 2. And that is shared by 3 and 4. That's why it's possible you have to have 2 modes, 3 modes, 4 modes, 5 modes, and many more. So pwede wala, pwede nga isa lang ka mode, pwede nga duha ka mode, 3 modes, 4, 5, 6, 7. It depends on your data set. Questions or clarifications, moms and sirs?
None, sir.
None? Okay, good. Thank you. Take note that in a symmetrical distribution, like this normal curve, for example, the mode, the mean, and the median are all located at the center of your distribution. However, in a positively skewed distribution, by the way, as you go to the left, the scores here become smaller. As you go to the right, the scores become higher. Now take a look at this. Take a look at this distribution. Are majority of the scores high or majority of the scores low? Take a look at this right skewed distribution. Are majority of the scores high or low?
Hi, sir.
Ang dire,
Low pala, sir. Low.
low, di ba? Kaya nga, it means
Yes,
ang
sir.
gold ko dire ayon sa right, sa left side, and ang laba nga ikog ara sa right. Skewness means tailness, no? Ang laba nga ikog. Kung ang laba nga ikog ara sa right, meaning to say, gamay lang nakakuha sang high scores. Gamay lang nakakuha sang high scores. And many of the scores are low. That's why in a right skewed or also called positively skewed distribution, the mean is greater than the median, meaning if the mean is greater than the median, meaning many of the scores are low. Damo nubo nga scores or damo nubo nga data. However, if the long tail is at the left and the bulge is ara sa right, it means nga gamay lang ang nakakuha sa low scores and many of the people got high scores. This is an example of what we call left skewed or negatively skewed distribution. Okay? In a left skewed distribution, many of the scores are high and there are only few low scores. Okay? So therefore, putang tayo naghatag ka quiz. Tapos damo nubo, meaning right skewed na. Kung naghatag ka sang quiz, damo taas kagamay lang nubo, meaning left skewed ina. Pero kung naghatag ka quiz, many got average scores, gamay lang nubo, gamay lang taas, that's a symmetric distribution. Okay? I hope it's clear with you. Remark, the latter two relationships are always true regardless of whether or not the distribution is unimodal. Okay. All right. I hope it's clear. Questions about measures of central tendency. Questions? No question? Okay. Let's proceed to measures of variation or dispersion. If measures of central tendency would tell you at what certain value the data would cluster, measures of variation, dispersion, or variability, on the other hand, would tell you of the spread of the data. For example, if this point here is the measure of central tendency, these are the actual, and these points here are the actual scores, measures of variation or dispersion would tell you how far the scores are from the mean, for example. And there are many measures to do that. So, but for now, we will discuss range, variance, standard deviation, and you have your population variance and sample variance as well. No? The same with standard deviation. So a measure of variability for a collection of data values is a number that is meant to convey the idea of spread for the data set. Remember yesterday, my example? Students A and B have the same average or same measure of central tendency, but they have different spread. No? Kahapon, in my example yesterday. That's why we will now discuss this one. Consider this. The following are two sets, male and female, in a particular quiz. So set A is the set of males. Set A is male. Their scores are 3, 4, 5, 6, 8, 9, 10, 12, 15. Set B is a set of females. And the The females have scores 3, 7, 7, 7, 8, 8, 8, 8, 9, 15. Okay. Now, let us compute for the mean and median of each. Okay? So, ang N naton for each is 9. How come 9? Because there are 9 students, 9 male students. There are also 9 female students. Okay. I'll give you a few moments. Please compute for the mean and the median. Okay, paladasig kita. All people whose surnames are from A to K, kung ang imo apelyido from A to K, do letter A. Find the mean and median of letter A, of males. If your surname is from L until Z, find the mean and median of B or that of females. Okay. I'll give you a few moments, please. All right. So now, after doing this, to determine certain measures, no? Let's go to analyze. Okay. Let's click. After you go to analyze, you go to compare means. And in compare means, sa right side, you go to means nga part. Then, okay, take note ka, analyze, compare means, then means. Okay. So you see there, we have the dependent list and we have the independent list. Normally, the independent list is where we put the nominal or the ordinal data, whereas the dependent list is where we place the scale data. So sex, saan pupunta yung sex? Sa independent or sa dependent? Sex
Independent, sir. Independent.
Independent. So highlight sex and click the arrow going to the independent list. And the family income will go to the dependent list because that's your dependent variable. Now, you might be asking, okay, sir, I want to compute some measures of central tendency and variability. To do this, you can go to options and you could see, no, on the left side are the different statistics na gusto mo i-compute, no? You have median, group median, standard error of mean, sum, and many more. Kung ano ang sa right, yan yung ko-compute niya. So you see mean, number of cases, standard deviation, and so on. Let's say ang gusto ko computeon are mean, number of cases. Okay, halimbawa, no? Mean, number of cases, standard deviation. Ano pang gusto ta? Let's say I would like also to compute for the median here. I would like to determine the minimum and maximum. So here, I would like also to compute for the range, diba? Range is highest minus lowest. I would like also to compute for the variance, diba? May variance to kagina, standard deviation. Ano pang gusto ta? You can choose whatever statistic you like here and place it here. Let's say this is what I like only. And after doing such, take note ha, if you don't want that statistics, you can place it back here. You can highlight it and click it. Kung sa left na siya, meaning you will not compute for it. But if you want to compute it, place it on the right. Then if you are done doing it, click continue. And click OK. And when you do that, the third window will pop out. And this third window is what we call the output view of your SPSS. The output view is where you could see all the computations or all of the statistical analysis you wanted, no? So take a look, oh. So meaning to say, how do I interpret this? There are 16 all in all. There are 16 respondents all in all. Excluded, tanan sila wala, tanan sila dala ara, no? Ang total, there are 16 of them, of which 9 are males and 7 are females. The mean, standard deviation, median, minimum, maximum, range, and variance of the males is in this row, whereas this is the n, mean, standard deviation, and so on, of all the females. So kung tanawon ta, that's why you see mas organized siya, di ba? All in all, 16 sila. Ang mean sa tanan is 70,875. The mean income of the males is 67,000 something. For females, it's 75,000 something. Ang median sa tanan is this. So you see, no? This is what is beautiful with SPSS because it's just a few clicks and you can determine everything with it. But normally, ang sa research naton, ang kinahanglan tama lang usually is n, mean and standard deviation. But if you need this other information, you can still use the method I mentioned earlier. Questions? Or clarifications po? None? Okay. So this time, di ba, in terms of sex, ning inubrata, let's do this in terms of ano ba? Let's go back. Let's say this time, I would like to do it in terms of civil status. Anong gusto ta? Tell me again what to do. Could somebody please open his or her microphone? Tell us. Anong steps? Anong una? Diin makadto.
Analyze. Go to analyze.
Analyze. Tapos?
Compare means.
Compare means. Dayon? Means. Okay. Notice mo, ara siya Japon. Why? Because in SPSS, if you have done this, no, in this case, the last test you perform on the certain data set is still there. So, di ba? So, ang sex, we don't like sex anymore. So, place sex, balik here. And this time, I would like to have it in terms of civil status. So, click civil status and put it in the independent list. Then, click OK. So, you go down. And this is how it looks like. So, you see, no? So, you could see, ang total dire, guys, tanawan yung last column nila, ho. Take a look at the last column. In terms of sex, ang last column yung tanawa. Ang total. Tanawa man ang total in terms of family income. In terms of civil status. Are they the same or are they different? Ang last column sa total. In terms of sex and in terms of civil status. Di ba parehas lang?
Yes, sir.
That's why, regardless kung ano pa naging compute mo, kung same data set ang ginhalinan niya, expect that you will have the same total. Okay? But you could see now the n, the mean, standard deviation, and so on. For those who are single, there are 7 who are single, 6 who are married respondents, and 3 who are widow. And that's what's beautiful with SPSS. It's just a few clicks. Questions or clarifications? And what's also good here is that you could save your data. For example, if I go back to my data, later on, if you would like to change it, no, you could save. So click File, Save As. And here, for example, data set. Okay, for example, I write here data set. And you can choose a folder where you can save, no? In my case, let's just do it, say, sa desktop. Okay. Then, after encoding, you can click Save. So you see, you can now close this data if you wish. No? And if you wish to solve, if you wish to save this, the output or the results, you can also do a similar thing. You click File, Save As. Then I would like to save this in the desktop. And let's say output let's say the output results. Okay. Then click save again. And you can close them, no, if you wish. So if you close this, just click yes. And if you wish, you can go back to it. It's here in the desktop. And you can open them or close them whenever or edit them whenever necessary. So it's here, no? So you see, it's there. That's the beauty of SPSS. All right, questions?
Kung online, sir, hindi na siya, sir. Kung online, sir, hindi, kung wala online, sir, hindi na siya magana or hindi mo na siya magamit.
Kung wala, ma'am?
Kung wala ba na signal or hindi online, hindi na siya pwede magamit.
Basta ma-download mo na siya, ma'am, and installed in your laptop, it does not require, basta ma-download mo na kag-install, it does not require internet connection.
Okay. Thank you, sir.
Welcome. Some more questions? None? Or may ara pa?
None so far, sir.
None? Okay. For the meantime, now that you have been acquainted on how to use the SPSS to determine some measures of central tendency and variability, then this time let's have, suppose you have these results already. Let's write descriptive textual discussion and tabular data display of your demographic profile and results. Okay. But before that, I missed a very important point. So suppose you would like to determine how many are in terms of sex, how many are males or females? In terms of civil status, how many are single, married, or widowed? Because later on, you will be making your demographic profile, no? Your table for your demographic profile or for the personal profile. So to do that, you can click Analyze. Click Analyze. You go to Descriptive Statistics, and you can click Frequencies. Now, click Frequencies, and you could click sex and put it in the variables part. You could also click civil status and put it there. So for example, if you have other nominal or ordinal variables that have labels or value labels, you can place them also here, no? For example, nationality, grade level, position, something like that. So you could place it here as many as you like. Then after such, you could click OK. And it says here, in the statistics box, valid is 16, missing is 0. That's for sex, meaning for civil status as well, valid is 16, missing is 0. This means to say that the software was able to check that your data is complete if the missing is 0. So you could see for sex, frequency is 9, and males, there are 7 females and 16 ang total. For the percent, 9 males, and 56.3 of the respondents are male, whereas 43.8 of the respondents are female. In a similar manner, and the total is 16, which is of course 100%. So the total here is also concerned here, is also the same here. There are 7 single, which comprise 43.8% of the population or of the sample. 37.5 of them are married, and 18.8 of them are widowed. So to do this, for example, if you wish, no, you could verify this with your calculator. So for single, 7 divided by the total, which is 16. 7 divided by 16 and multiply it by 100, it will give you approximately 43.8. That's why it's 43.8% there. I hope it's clear with you. So that's how you do it, no, for your demographic profile. Now, suppose that you are able to solve everything using SPSS. It's high time now that you write your descriptive or textual discussion and tabular data display, no? And our focus today will be a portion of your demographic profile and results involving your mean and standard deviation. So, but our focus for today is on writing textual discussions on the demographic profile and results in relation to statistical tables. So I hope that you are ready as well. Note there are many ways of writing textual discussion of descriptive tables, and they vary based on style, based on institutional format, or based on what the panel member wants. You are free to create your own discussion as long as you do not deviate from the essence of your data. Presume that your audience knows how to read. Give them the presumption of literacy. And what does it mean? It means, therefore, that you have to provide other or higher interpretation aside from simply repeating the information on the table. So provide a higher interpretation or other interpretation. And in the actual thesis, the text or the textual discussion comes first before the tabular data display. No? So the text first before the table, or the text followed by the table. Now, transition words like also, moreover, furthermore can be used in the discussion. But as much as possible, do not break tables. When I say break tables, because others are like half of the table is on page 1, the other half of the same table is on page 2. No, that is not allowed. As much as possible, one table should be on one page only. Make sure that the entirety of a table, including table number and the name of the table, is located in one page. You have freedom in writing, but maintain objectivity at the same time, because quantitative research is objective research. And be reminded as well that technical or scientific writing is not the same as journalistic writing. Probably it could be in some sense, no? For example, if you are writing editorial, probably, or if you are writing the news. But if you are writing a feature story or let's say human interest story, it's not like that. In journalistic writing, sometimes we can use idioms, no, figures of speech, flowery words. But in quantitative research or studies, that is highly discouraged. As much as possible, go straight to the facts, follow the KISS principle. KISS principle, keep it simple, keep it short and simple if possible. And take note, no, it varies again per institution. For our class only, use the following specifications. So use Times New Roman, font size 12, in a short size bond paper. The orientation is portrait. The margins is 1.5 inches on the left side and 1 inch margins on the other sides. And the spacing within the table is 1, and within the text is double space or 2. Don't worry, you will also be provided with this information later. Let us have an example. Let's talk about demographic profile. For example, here's a situation first. You would like to determine the average weekly allowance in Yuan of randomly selected learners of Xiamen Junior High School for 2021-2022 during the time of COVID-19 pandemic. You would like to determine their demographic profile and to interpret means, and you intended to use the following scale. Example lang ni ha. If their mean allowance in Yuan is 401 and above, that's high. 201.00 to 400.99, that's average. And if it is 0.00 to 200.99, that's low weekly allowance. Again, this is just an assumption. No? So, for example, you found out nga mo ni. Okay. Entire group, 400. Okay, you might be asking, sir, di naghalin in terms of sex, 250 are males, 150 are females. You might be asking, sige, diin naghalin ang 62.5% nga ini. Di ba ang total is 400? So to do that, let's say I have my calculator. To do this, di ba that's 250 males out of 400 in the entire group. And here is the sample size, and percent is the, of course, percent. So divide 250 by that from the total. 250 divided by 400. And whatever the result, multiply that by 100 equals. So you see 62.5, meaning this 250 is 62.5% of 400. Okay, let's fill in, Be. In a similar way, 150 divided by 400 times 100 is 37.5, no, percent. Sige, Be, for grade 7, let's fill it in. Let's say for grade 7, pila. Use your calculators if you wish.
0.5.
28.75, sir.
Let's see if that's correct. That would be
29.
115 divided by 400 times 100. Okay. 28.75, right? But for our class, let us express only the percent into 1 decimal place lang, ha? Okay lang? So this will be 28.8. Okay? We'll just round it to the nearest 1 decimal place. Let's have 28.8. And if you did everything, it will look like this. Okay? Ginubra ko na lang tanan, ha? So grade 10 is 20.8% and so on. Now, so for example, in my demographic profile of junior high school learners, let's say that's the name of the describing this table. I placed there frequency count and percent were used to determine the demographic profile of respondents. There are 400, and I place here, no, inside the parentheses, 100%. This is the frequency, this is the percent. Learners who served as the respondents of the study. Ang sa red, amo na siyang discussion sa sexo. I wrote here, in terms of sex, di ba lang mas damugid man ang males, no, kaysa sa females. I wrote here, majority of the respondents are male. And I wrote here, N equals to 50. And while the remaining 37%, 37.5% of the respondents are females. So it's your call. Depende man ya. It's your call if you will report the percent only, if you will report the frequency or the N only, or if you will report both. As long as you use other or provide higher interpretation. Wala akong nagambal nga, it can be seen, no? Notice nyo nagambal akong word nga majority. Kaya it's understood na kung mas taas siya compared sa isa, majority na ina, no? So sige be, if we complete, how about this one? So this discussion for black part, amo na siyang sa entire group, oh. The red part, I emphasize it, no? This is for this part. How about for the last part, for the grade level, be? You can make your own, no? You can make your own. But in my case, I wrote it this way. Okay. When grouped according to grade level, grade 7 learners, I placed the N equals 115, occupy 28.8% of respondents, followed by grade 8 learners. Tapos, for grade 9, I placed, di ba, 24.2? That's nearly a quarter. Nearly a quarter, quarter means 25% eh. Lapit man siya sa 25%. So I wrote nearly a quarter of them are from grade 9. While the remaining 28, while the rest are in grade 10. Table 1 displays the demographic profile of respondents. Take note ha, it appears this way But in reality, in your actual research paper, dapat mauna gid sa babaw gid dapat ang inyo sa baba sa bond paper na bala. Dapat this one should be first, and after which this will follow. Okay, this table should be below or under your text. This is just an example. Questions or clarifications about the demographic profile? Example lang. None?
No, sir.
Now, how about kung results and discussion naman? This time, I will be utilizing mean and standard deviation.
Aba,
Okay? How about kung may ara ka na sa mean kag standard deviation? Remember, mean and standard deviation are partners, no? For example, after mo survey, amo niyang results. They found out that the entire group has a mean of 400 sila. SD stands for standard deviation. Let's say, assume taha nga nag-SPSS kita and we know everything. The standard deviation is 8.75. The mean allowance of the entire group is 405.85. And you see, no, we have here the legend sa dalog. No? Your footnotes, remember? Your legend. Di ko niging kuha ang ini. This data, this is, ginkuha siya sa, ari siya ho. This was the scale that was presented earlier. That's why normally, before proceeding with your data collection, as much as possible, it should be clear in your chapter 3 kung ano ang scale na gamiton mo. And here are the scale of means here. Oh. So it's here. Okay. Let's say for males, 250 ang males kagina, di ba? Their standard deviation is 5.57. And their mean is 389.50 yuan. For females, 150 sila. The standard deviation is 10.83 with a mean of 433.10. Ang pamangkot, di ko naging kuha ang average. Nga why I place average here? What's the basis? How come I wrote average dire? How come high? This is average. How come this is high?
Sa legend,
Sa
sir.
legend,
Sa
sir.
legend. Ang legend, gingamit ang mean or gingamit ang standard deviation?
standard.
This is
Mean.
the mean. Tandaan nyo na ha, magbutang kita ganisang legend later on sa tables naton, ang ginagamit kid na ang mean. So for example, ang 405.85, it belongs to the 401 and above. That's why high, ibutang. This is averaged. 389.50 belongs in the 201 to 400.99. That's why nagbutang ko average, iniya high. Sige, ang iniya be, ang next one, sa grade level naman be. What about for grade 7? Just tell us. Grade 7 is?
High, sir. High.
Hey, sir.
High. Sunod. Grade 8.
Average.
Average, tama. How about grade 9?
Average.
Average.
Average man. Dayon,
High.
ang grade 10?
High.
High, sir.
High. Okay. Oh. There. Take note that this data is fictitious and you just make it up. But it's just an assumption nga na kumpleto mo ng study. And that's why it looks like this. Now, next thing is, let's make the text for this. Okay, ari siyang first part, no? I just made the first part. Okay. Take note ha, in reality, dapat black ni tanan. Okay ha, dapat black ni tanan ha. It so happen lang agin color coding ko lang anay for you to see nga, okay, amuning connection niya gali sa table. It could be seen that the respondents, okay, sa black na part, no? It could be seen that the respondents' weekly allowance as an entire group. Then I reported M. M stands for mean. 405.85, comma, SD equals 8.75 has reached the high level. That's the entire group pa lang. Take note, magsulat ka na galing, no, sa table or sa text, dapat mauna ang mean, then comma, standard deviation. Tapos, din naman nga part to, in terms of sex, it could be seen that males then report the mean and standard deviation ng male has reached the average level, has an allowance, has allowance that reached, has mean allowance that reached the average level, which is lower. Kaya di ba mas taas yung high compared sa average which is lower to those of females. And I reported also the mean and standard deviation of females. Okay? Whose weekly allowance reached the high level. Sige. Sige be? Try nyo ba ang grade 7? Try nyo ba ang sa last din nga part to? Try formulating your own be. Take note, 1 sentence or 2 sentences will do. Sige, I'll give you a few moments. Try to formulate a statement or a sentence nga naga-describe dira. Okay, I'll pause first, ha? Anyone? Don't be shy.
Can I try, sir?
Yes, ma'am, go ahead.
For the grade level, grade 7, which has a mean of 401.10, and the standard deviation 401.10, and grade 10 was with a mean of 447.45, and standard deviation, which is 14.80. 14.80 has weekly allowance that reach high level. On the other hand, grades 8, which has a mean of 375.40, and standard deviation, which is 4.78, and grade 9, which has a mean of 389.50, and standard deviation, which is 10.10, has reached the average level of weekly allowance.
Nice. Very good, ma'am. Thank you. So, in my case, I think what I did is similar with ma'am, no? So, it's just the same. I place here, one categorized according to grade level. Ang words ko ya is, both grade 7 and 10, okay, I place here mean and standard deviation, have high level of weekly allowance, while the rest of the grade levels, mean weekly allowance, reach the average level. Take note, you don't need to report everything yet, no? You may report only some depending on you. Okay? Kung gusto mo, kung damo sila, you may emphasize only the extremes, like the highest level or the lowest. If ever, no? Kung damo-damo sila. Okay, thank you for that, ma'am. That is well done. Okay, good. Questions or clarifications? Because later on, in your next problem set, you will be making something like this. No question? Okay. If there is none, that ends the first presentation. Yay! Okay. Let's have another one. So don't worry, no? We have finished. And I hope that you could still recall that population parameters are computed from populations, whereas statistic is computed from a sample. That's why if you computed of the mean of the population, that mean is an example of a parameter. And if you computed of the mean of the sample, that mean is a statistic. I hope that you could, you know the difference. Thank you. Later on. For now, let's have the 68, 95, and the 99.7 rule for normal distributions. For normal distributions, 68% of the area under the curve, if we say AUC, that means area under the curve, is within plus minus 1 standard deviation of your mu or population mean. 95% of the area under the curve is within plus minus 2 standard deviations or within 2 standard deviations. And 99.7 of the area under the curve is within 3 standard deviations. So here, if you go only from here, if you draw there a vertical line and draw here another vertical one, then the total area under this curve is set to be 68%. If it is within 2 standard deviations away, then the area, everything here under the curve is 95%. And if you go from -3 to 3 or 3 standard deviations away from the mean, then the total area there under the curve is 99.7%. And if you could see, we still have 0.3%, and that 0.3% is in fact divided equally in these two smaller endings here. That's why the areas that are not within 3 standard deviations away would represent only, that are either going to the left or either going to the right. The total of that is just 0.3% in all, which is quite negligible or a very small probability. Let's have the following example. The Wechsler Adult Intelligence Scores normally distributed with the population mean of 100 and a population standard deviation of 15. We have this notation. This notation actually indicates that you have a normal distribution with 100 as a mean and 15 as standard deviation. This is in fact a notation. So for that, it means to say that 68% of the scores are within mu plus minus your standard deviation. Remember, your mu is 100. So if you subtract it by 15, 100 minus 15, that's 85. Then to get the higher one, you add 15. 100 plus 15, you get 115. Which means to say that approximately 68% of the scores are within 85 to 115. If you have 2 standard deviations away from the mean, then you have 100 minus 2 times 15, which is 30. So that's 70. 100 plus 2 times 15. 2 times 15 is 30. 100 plus 30 is 130. This means to say that around 95% of the scores ranges from 70 until 130. And lastly, if you have 3 standard deviations away from the mean, then you will subtract the standard deviation thrice and add it thrice as well to determine the range of values. So if you wish, 100, you subtract it thrice, minus 15, minus 15, minus 15, that's 45. 100 minus 45 will give you 55. And you will add also 3 times 15, which is 45. 100 plus 45, it's 145. This means to show that those people who got 55 to 145, it is expected that there are 99.7% of them. Again, assuming that they follow a normal distribution. So this is it. This is how it looks like. So from here, you subtract by 15, 85, minus 15, 70, minus 15, 55. Plus 15, if you go to the right, 115, 130, 145. So 68% here, have you see, are 85 to 115, 95%, 70 to 130, and from 55 to 145, approximately 99.7% of them.
Okay, do you have any questions or clarifications so far? Because if you could notice, no, ang standard deviation balaan, if the mean is always located at the middle, no, if it is a normal curve or distribution, you are subtracting the SD as you go to the left. So 100 minus 15, 85, 15, 70, 55, then you add it as you go to the right. That's why one standard deviation away, that's 68% here, that's based on the empirical rule, or in the 68, 95, 99.7 rule. Take note, in reality, it is not really that, but these are the rounded or estimated values. Okay, so that's why within two standard deviations away, to the left, 1, 2, so 70, to the right, 1, 2, 130, so 95% are within two standard deviations away, meaning the area bounded by this line or segment, this horizontal axis, and this curve here from 70 to 130, the area there is 95% or 0.95, because the areas here are all about probabilities. And from 55 to 145, approximately 99.7%. So if you might be asking, sir, how about those that are less than 55 and greater than 145? So their total or combined probabilities is around 0.3%. May pamangkot pa kita so far or clarification before I proceed? Anyone? Any question? No question?
No, sir.
Okay, sige. So I'll just continue ha, lapit na lang.
I hope it's clear with us. Now, let's talk also about the symmetry in the tails. Because the normal curve is symmetrical and the total area under the curve or AUC is exactly 1, we can easily determine the area under the curve in the tails as well. For example, if we are talking about 95% here, so it's 2 standard deviations away, right? If you could still recall. So here, from 70 to 130, that's 2 standard deviations away from the mean. So the area under this curve is 95% based on the rule I gave earlier. So if it's 95% here, then remember the total probability is 100%. And so subtract it by 95. So you have 100% minus 95%, that's 5%. But since these two tails here are actually symmetrical with one another, there's also symmetry. It means to say that the areas in these two are in fact equal as well. That's why 5% divided by 2, you get 2.5% here. This means to say that 2.5% of the people there have scores or have scores below 70, whereas the remaining 2.5% also have scores that are higher than 130. Let's talk about male heights. For example, you have male heights that represent a normal distribution with a mean of 70 and a standard deviation of 2.8. So if we talk about within one standard deviation away, so of course from 70 you subtract by the standard deviation. 70 minus 2.8, that gives you 67.2. From here, 70 plus 2.8, that gives you 72.8. And according to the rule we discussed earlier, to the empirical rule, 64% of the scores or 68% of them should lie between one standard deviation away from the mean. That's why it is expected that 68% of them are within 67.2 and 72.8. So what does this mean then? Since this is perfectly symmetrical and that the total probability under this curve is 100%, then 100 minus 64, or sorry, it should be 68% there. I think it's wrong here. Please note this should be 68%. Thank you. That's why if you have 100 minus 68, that is in fact 32%. But since these two tails here, both going to the left and both going to the right, are symmetrical, so this 32 will be divided into 2. So that's why you have 16% each of these tails. So 16% of the areas or of all the scores are below 67.2, whereas 16% also of all the heights are above 72 or higher than 72.8. That is because of symmetry. Okay? By the way, the heights here and standard deviations are in terms of inches. Moving on. If you could still recall in our first discussion, we have two branches of statistics. One, it's what we call your descriptive statistics. This involves the organization, summarization, and display of data. Like if you are utilizing frequencies, ranks, measures of central tendencies, measures of variability, percents or percentages, that's descriptive. But we have also discussed another one, which is what we call inferential. This involves using a sample to draw conclusions about your population. And so from this point forward, our focus is not only descriptive, but rather inferential. Like, given a certain data set, what possible conclusions can we form out of them? What possible inferences, what possible generalizations could be formed out of the data that we have? Speaking about inferential statistics, it allows conclusions about the population to be generated from sample data. It is applicable when probability sampling is used. And that's why if you could see, if we have probability sampling, just like the one that we mentioned last time, remember, if you have your random sampling, your simple random sampling, like your fishbowl or your lottery method, your systematic sampling, your stratified random sampling, your cluster sampling, what else? And we have your multi-stage sampling. That's why it's really applicable when probability sampling is used. Inferential statistics is founded on the theories of probability. Results are questionable when non-probability sampling is used. That is why it is very important that you know what sampling technique you utilized, because later on it might have an impact or it might affect the type of generalization or conclusion that you could get from your data. And the branches of inferential statistics are the following. So we have here, in doing inferential statistics, you could do either hypothesis testing or estimation. When we speak about estimation process, you could estimate either using a point or you could give either a point or an interval estimate. We will discuss it later on. And aside from estimation, you could also have what we call hypothesis testing. This includes parametric and non-parametric statistics whenever it is applicable. Okay? Now, it is important to determine an appropriate inferential statistical test of hypothesis. So, if you could see here in this diagram, there are actually many ways of determining. So it's like there's some sort of a diagram or a flow chart on what to do. And the level of measurement is an important indicator in the choice of statistical hypothesis testing procedure. Is your dependent variable nominal, ordinal, interval, or ratio? It's important that you know them because it would actually help you to determine what particular statistical tools or techniques are applicable. Also, parametric tests have more stringent assumptions before they can be used. Data must be at least interval, and the distribution of the data must be normal or approximately normal. In reality, having a perfect normal distribution is most likely impossible. But however, it could be approaching normal or approximately normal, but perfectly normal, not that much. And we also discussed.
Do you have any questions or clarifications so far? Because if you could notice, no, that's why gin-discuss ko anay una ang normal curve about the normal distribution, because as much as possible later on, if we are going to use parametric statistics, then the concept, your data should be approximately normal, or it should be somehow more of symmetrical curve. Do you have questions or any clarification so far before we proceed? Before we have our lunch?